Welcome back. Now we have this update slide displacement function, and it's getting the elapsed time from our timer, slide timer, and then it's getting the curve value from our curve called slide displacement curve, and then we're setting slide displacement to our curve value times max slide displacement. So now we have a slide displacement float value that we can use to displace the slide on the pistol when we're firing it. Let's go back into the editor now, and we're going to go ahead and come into our folder for base weapon where we have an AR animation blueprint and an SMG animation blueprint. We're going to go ahead and create a pistol animation blueprint. So let's right click and create a new animation blueprint by going to animation and animation blueprint. We're going to base it on anim instance and choose Bellica skeleton, unless of course you're using the gun asset from the GitHub page, in which case you're going to use the skeleton for that mesh, which should be Bellica gun skeleton. So make sure you're using the skeleton that the actual mesh of the gun is using. Otherwise, you won't be able to use this animation blueprint with that weapon. Click OK, and we're going to call this Pistol AnimBP. Now let's open Pistol AnimBP. Now we can right click and create a state machine, and I'm just going to call this state machine default. This is just like what we did for the SMG and the AR. We're going to open default, create a state, call this default, and leave it empty. We don't need anything in there. Now we have our state machine. Now let's go into the event graph. Here is where we need to retrieve our slide displacement amount. So we're going to need a variable for the weapon class. So let's create a new variable, and we're going to call this pistol. And we're going to set the type for this variable to base weapon BP. Now in event blueprint update animation, which is like the tick function for the animation blueprint, we can get pistol and check to see if it's valid. Now the very first time we check, it's going to be basically null, so is not valid will fire. In that case, we can get the owning actor, and we can cast this to base weapon BP. And once we cast this, we can use it to set the value for pistol. So we're going to get a setter for pistol and set the value. So the first frame, we're going to get this and set pistol, and then the next frame is valid, should fire because pistol will be set. Now each frame, we want to update the value for our slide displacement, which means we should create a local variable here on Pistol AnimBP for that slide displacement. So let's add a new variable and call this slide displacement. And we're going to set the type for this variable to float. And we're going to set this here in update animation. So I'm going to drag off and use set displacement. And we'll get our pistol. And from the pistol, we're going to type slide displacement and get slide displacement. And we can also take this output pin and plug it in there. And that way we're updating slide displacement every frame. So since we're getting slide displacement from the weapon class every frame, we can now use this to transform bones on our mesh. Let's go back to the anim graph. Here we have our default pose, and we're going to right click, and I'm going to type transform modify and use a transform modify bone node. Now if I take the pose from default and plug it into component pose, we get a local to component transform, and if we plug the output back into output pose, we get a component to local, so it goes back to local space. Now what we could do here is we can choose how to transform our bone and which bone to transform. So with transform modify bone selected, we're going to choose the clip bone on our pistol. Now this bone, if we go back and take a look, we can go into weapons/meshes and we can get Bellica pistol. And if we look for pistol, we'll see that the bone for the slide is called pistol slide. So back on the transform modify bone, we're going to use pistol slide. So there it is, pistol slide. Now we're going to use our slide displacement value. So let's get slide displacement, and from this we can make a vector. Now let's take a look at Bellica pistol, and we'll look at the slide pretty closely this time. I'm going to move the weapon out of the way. So let's move the weapon, and we'll take a look at the pistol slide bone. And notice if we zoom in, the pistol slide has its y-axis pointing forward. If we grab the green, it's kind of hard to see, but we can grab the green arrow and we're sliding it forward and backward in the bone's local y-axis. And the positive y goes forward, negative y goes back. So we're going to want to transform the bone's local y-axis value. So here in transform modify bone, we're going to pass in the translation, and slide displacement is going to be plugged into the y. Now x and z can be 0 because here in transform modify bone, we're going to use translation, and for translation mode, we're going to use add to existing. So it's going to take the current transform, take that translation, that location vector, and add slide displacement to that. So we're adding to it each frame. Now the translation space needs to be in component space because we're going to add to the local y of that slide bone. Now we can leave rotation at ignore and scale at ignore because we don't really want to rotate or scale this bone. We only want to move it in the y direction. Now slide displacement is going to go up and then come back down, which means that we're moving the slide in its positive y direction, but we saw that the positive y direction was forward, right? This is the positive y direction, and we want to blow the thing back like this. So what we're going to do is simply take our slide displacement and multiply by -1. And we'll plug that into y instead. Okay, so we should be able to transform the bone. So let's go ahead and compile, save, and let's go into our weapon data table and select pistol, and let's find our animation blueprint called AnimBP. We can go ahead and select the drop-down, search for pistol, and we can set this to pistol AnimBP. So go ahead and save that. So now we have this pistol animation blueprint that we're using for the pistol. Now let's click on this item here, which we have our weapon type set to pistol. Let's move it once, and now we can double check to make sure that it's using that pistol animation blueprint. So we can click X on the search bar and click item mesh, and now we can see the anim class is pistol AnimBP. So it's using that animation blueprint. So I'm going to go ahead and click Save All, and we can go ahead and try this out. I'm going to go ahead and hit play, pick up the pistol, and swap to the pistol. Now it's kind of hard to see if it's moving or not. So what I think I'll do is I'll go ahead and change slide displacement to go into the X, so that way it'll move sideways. Now this is going to look kind of funny, but at least we'll see if it's moving. And I can even multiply this by a bigger number, say -10, and that'll make it a little bit more exaggerated. Let's go ahead and play, pick up the pistol, swap, and fire. Oh, looks like it's moving. It's really, really fast, but it's sliding to the right. You can see that. Yeah, it's sliding to the right. So it's moving really fast. So we might actually want to make this longer than 0.1 seconds. Let's go ahead and select the rightmost key on slide displacement curve. And let's set this, instead of 0.1, let's go to maybe 0.2. and I'll just leave everything else as is. Now, this means we'll also have to change our slide displacement time that our timer handle is using. So slide displacement time in the C++ file from point 1 to point 2, but I'm also going to expose it to blueprints because it would have been handy to be able to adjust it in blueprints instead of coming back and trying to compile everything again. So let's make this edit anywhere. Blueprint read only, category pistol, meta allow private access. And let's go ahead and compile this. So we're going to have a slower time, which means that the pistol should not fire faster than 0.2. So we're going to go to the auto fire reset time, auto fire rate we called it, and make it 0.2. So let's save that. And we can go in here and move the weapon. And now we can go ahead and test this. Now we are moving the slide, but it's a little bit hard to see because it's really moving exactly in the direction that we're looking. So that makes it a little harder to see. And in order to see this a little bit better and to make this a little bit more realistic, we can rotate the weapon as well. Now, if we want to rotate the weapon, let's take a look at our pistol again. And if we search for pistol, and select that. This time I'm going to simply grab the pistol and move it up. I'd like to actually rotate the pistol up like this and back down. So if we rotate the pistol up, that gives it a little bit of recoil. And so I'd say about 20 degrees or so is probably good. And not only will the gun go back a bit, but when the slide blows back, we'll be able to see it a little bit better. So let's go ahead and add a float value to weapon.h, and this one will be for our max recoil rotation. So let's say float max recoil rotation, and we'll also make this edit anywhere blueprint read only, and we'll say max rotation for pistol recoil. And I'll set this to a value of 20 for 20 degrees. So 20.f. Now let's compile this. And back in our pistol NMBP, I'm going to add another variable for our recoil rotation. So let's go ahead and add a new variable. And we'll call this recoil rotation. And it's going to be a float. And once our C++ code is done compiling, we'll set this recoil rotation. Now, in the meantime, in AnimGraph, we're going to use another transform modify bone. So let's go ahead and do a right click and transform modify, use transform modify bone. And we can go straight from our last transform modify bone. And from that, we'll go back to local space. And what we're going to do for this transform modify bone is we're going to get our recoil rotation and make a rotator. Now here in our Bellica pistol skeleton, we want to rotate about the x-axis, which means we're affecting the roll. If we're going about the x-axis, we are adding a roll amount. So let's go ahead and in this rotator, we're going to use recoil rotation for the roll. And we're going to pass this in for rotation. And for the second transform modify bone, we're going to choose the actual pistol itself. So we're going to search for pistol and use the pistol bone. Okay. So that looks good. Now for translation, we're going to ignore, but for rotation, we're going to add to existing and we're leaving it in component space. So now the pistol should rotate backward when we fire it and rotate back again because recoil rotation is going to follow the curve. Now we need to update this, and we need a variable in our C++ class to use to update this. So along with max recoil rotation, we're going to also add a float for recoil rotation. So I'm going to copy our slide displacement float and paste it down here. And this one is going to be recoil rotation. And the comment will say amount that the pistol will rotate during pistol fire. And we're going to update this. Here in update slide displacement, we're going to say recoil rotation equals curve value times max recoil rotation. So now this will be updated every frame as long as we're moving the slide. Let's go ahead and compile this. And once it's done compiling, then here in the editor, all that's left to do is update recoil here in the event graph. Okay, so we've compiled. So I'm going to go ahead and set recoil rotation by getting it from pistol. So let's get recoil rotation and set this and compile and save. And now we can go ahead and fire the pistol and see how this works. Now we can see that it's actually rotating, but it's rotating forward instead of backward. Oh, and we've broken some references, which means we'll have to go ahead and restart the editor, but that's not a big deal. Right now, I just want to use recoil rotation correctly. So I'm going to go ahead and multiply it by -1 here. In fact, rather than do it here, I'd rather do it in the event graph. So we don't have to do any mathematics here in the anim graph. That's not really the place for that. I'm going to do that for slide displacement as well. Let's go ahead and multiply both of these by -1 in the event graph. So we're going to get slide displacement. We're going to multiply by -1 and then set slide displacement here on our anim BP to the value times -1. And I'll do the same thing here for recoil rotation. I'll multiply this by -1 and set recoil rotation here. Okay, so now this should rotate the pistol the correct direction. So let's go ahead and fire the weapon again. And now we can see that it's going back the correct direction. Now we'll get rid of these errors as soon as we restart the editor. But what I'm going to do is, just to see this a little bit better, I'm going to go into our character blueprint. So character, shooter character BP. Now here in the blueprint, I'm going to take our mesh and rotate the mesh by 90 degrees. And now when we press play, we're seeing the character from the side view. So now we can see this a little bit better when we use the weapon. Let's go ahead and fire. And we can see that the gun goes back, and also the slide is getting blown back and comes right back. So that looks amazing. I'm going to go ahead and crouch just to make sure that this still looks good. Excellent. This is looking great. I'm going to go ahead and set this mesh to face forward again. We'll rotate it 90 degrees back. I'm going to compile. I'm going to save. And just to show you that everything is okay, even though we got those errors, that'll happen sometimes. You just need to refresh all the nodes by restarting the editor. So I'm going to save all and close out of the editor and restart it again. Okay, so we're back in the editor. I'm going to click open just so we can open all the assets that we had open. Here they are. Now I can go ahead and one more time, let's just rotate the mesh by 90 degrees just so we can see the beauty of what we've done so far. Let's go ahead and hit play. And we'll grab the pistol, swap to the pistol, and we will fire the weapon. That is beautiful. Now I'm seeing that the back arm is tweaking a little bit. That's our inverse kinematics. That's because we're trying to stretch the arm out a little too far. We can fix that by going into Shooter Anim BP and using our cached pose fabric pistol and compiling so that we can come up to our fabric for the pistol, and let's move it back a little bit so that it's not quite so forward. We don't want to stretch it out to where it's difficult to reach. So let's go ahead and pull this back a little bit. Not too much, just a little. Just about right there. I think that looks good. So we'll go ahead and use that. We'll save, compile, and let's go down here and use our cache poses with fabric again. Compile and let's play. We'll grab a pistol, equip it, and we don't get that twitchiness anymore. Beautiful. All right, so let's go ahead and wrap this up. I'm gonna go back into Shooter Character BP, select our mesh and rotate it forward again by 90 and compile, save, go ahead and save all, and great job. We now have a pistol. We'll see you in the next video.